Hello everybody. This is a short talk which looks at the embodied carbon in passive house homes in the UK. Today we have a major climate challenge. The UK is legally committed to reducing carbon emissions to net zero by 2050, just to keep global warming below 1.5 degrees. There are many standards to help us reach this target. Passive house standard is a good one, and it demands no more than 125 kilowatt hours per metre squared per year of primary energy use. Passive house principles are simple. Basically, you provide high levels of insulation with no thermal bridges, and you optimise solar gain, as well as having mechanical heat recovery ventilation and a continuous air barrier. Currently, embodied carbon emissions are missing from this standard. Thus, the aim of this research is to understand how important embodied carbon emissions are in relation to different materials and whether the passive house metrics are currently fit for purpose. There are basically three embodied energy and carbon methods used. The first is input-output analysis, which basically uses measurements from different national economic sectors and attributes this energy intensity to individual products. The second is based purely on data related directly to the individual building product. The third is called hybrid analysis, and it combines the best of the previous two processes, making it the most reliable method. However, because of limited data accessibility, we use the process-based analysis for these two case studies. We also used a cradle-to-gate approach, which means examining all the factors from the point of extraction of materials to the point of the product leaving the factory gate. On the left, you see some typical passive house walling constructions. On the right. And below, on the right, you see an example of Brettstapel glueless timber solid wall construction. This glueless timber construction was used in the first case study, which was a house in Scotland. It was a large house with 300 metres squared of treated floor area, had a high level of wood fibre insulation, and it met the passive house standard. It also had solar thermal panels and a wood stove. The second case study is a much smaller home, only 127 metres squared. It uses brick external walling with aerated concrete block construction inner walling. It has just 300 millimetres of mineral fibre insulation. It also meets the passive house standard, but this time with no solar thermal system, but it does have a wood stove. When we look at the results from evaluating the carbon emissions from these two case studies, we see that in the timber house, the embodied carbon emissions are 452 kilograms per metre squared, but 136,000 kilograms in total. By contrast, the operational carbon emissions are about 9 kilograms per metre squared per year and 2,742 kilograms per year in total. This means that it takes approximately 47 years of operational carbon emissions to match the embodied carbon, making the embodied carbon very significant. Similarly, for the brick and concrete house, we see that the embodied carbon emissions are virtually the same per metre squared, but much, much lower when the house is looked in total. The operational carbon emissions are slightly lower, and also considerably lower when you actually look at the house in total. For this house, it's 61 years of operational carbon emissions needed before you reach the embodied carbon. Thus, the timber house has similar embodied carbon per metre squared, but it's twice as much in total compared to the brick and concrete house. The brick and concrete house has less than half the operational carbon emissions overall compared to the timber house. So what does this tell us? Well, it means we need to move beyond looking at rates of energy use and beyond energy efficiency factors. We need to look at the embodied carbon sufficiency factors. And that means including the overall size of the home, as well as the number of people living in the home. We need to understand whether the house is being used sufficiently. In other words, whether the number of people it was designed to be used for is the same as the number of people actually living in it. These factors, along with the embodied carbon, are currently missing from the Passive House standard. They're incredibly important as they illustrate the actual overall environmental impact per person and per home. Thus, the timber house was twice as large as the average family house equivalent in the UK, and that explains why the embodied carbon was so high. And it was more than twice the size of the brick and concrete house. However, only one person lived in the brick and concrete house, whilst 2 people lived in the former. And so when you take the number of people living in the home, then per person, the factors become much more similar in terms of embodied carbon. We didn't use sequestration for the timber house because we can't prove the supply chain, and we also can't prove whether or not the timber house will actually remain standing long enough to account for all the sequestration over a long number of years. Once this was removed, the embodied carbon emissions were surprisingly high for the timber house, and this was also due to its extensive concrete substructure. Thank you for listening.